All right, so we're doing integrals with some long division here. Notice my numerator is smaller than or larger than my denominator. So I put the denominator over here and the numerator over here. I fill in missing terms. Notice it goes x to the third, then x. So I fill in this with a 0, x squared, just to keep my organization. Then I ask myself, what do I have to multiply x squared by in order to get x to the third? And so that's an x, because x squared times x is x to the third. I write the answer to that question up here. And I kind of keep everything in line. Notice all my x's are here. X to the thirds would be here. X squareds would be here. Then I take this and I multiply it through. So x times x squared gives me x to the third. And I write that right there. X times 1 gives me x. So I would write that over here. Remember, keeping it in line. Then I put these parentheses here and here. So I know to change the sign. Because now x to the third minus x to the third gives me nothing. 5x minus x gives me 4x. And then I drop the 10 here. Now, since this result is a lower degree than this, I'm finished. If it's the same degree, I would keep going, but since it's a lower degree, I'm finished. So now this is that x, okay? And I'm going to add to it y addition because this whole thing is positive. Notice this remainder here divided by the old denominator over there. So the old denominator goes here. Your numerator, right? Or not numerator, your quotient ends up going here, and your remainder ends up going right there. And now I have two separate integrals. This is a simple integral. This is just, 2x x squared over 2. This integral here can be split into two separate integrals, okay? Each with a denominator of x squared plus 1, x squared plus 1. This one, you'll notice, is going to end up being a natural log, right? You just kind of factor out a 2. And then you notice that if I have a 2x, the numerator is the derivative of the denominator. So that's going to be your natural log, okay? Another way you could think about that is by doing a u substitution over here. I did it with a u substitution. So I'm going to let u equal x squared plus 1. And so there it is, x squared plus 1. Then I factored out a 2, all right, leaving me a 2x, all right? And, oh, I forgot an x right here. There should be an x right there because du is 2x dx. So sorry, let me add that little x in case you're looking at this. 2x dx. And therefore, that's where my 2x dx became my du. And now you just notice you've got a 1 over u. The derivative of that is, natural log of u. Resubstitute. This one here is a easy, or not so easy, but you hopefully should recognize this as a trig inverse. So I factored out my 10, leaving me 1 over x squared plus 1, which, if you look at your table of integrals, is just going to be on there. And then, so there it is. Oh, you got to add a plus c over here, plus c. All right, so there we have it, a crazy integral by long division.